Okay, hello everyone. Welcome to today's Green Business Fund technical webinar. Just to reiterate, this is the technical webinar on refrigeration. My name is David Tobin. I'm a chartered engineer and energy consultant at the Carbon Trust. This is one of 7 initial webinars that we've done with the Green Business Fund. Others include HVAC, motors and drives, lighting, compressed air, controls, and energy from waste. All of these are available online. If you go into the Carbon Trust Green Business Fund website, you can go through those and get information about those systems if you have those operating on your site. So I'll get us started. As I say, I'll give you a quick run through of the agenda today. So we're hoping to cover refrigeration more broadly, quite broadly, covering it really at all levels of understanding. So we'll be speaking in quite broad terms on refrigeration. So if you do want more detail, please feed that back in the questions. But this is aimed at kind of all levels of understanding. So we're going to go into some initial detail on refrigeration systems generally, about how the systems work and the typical types of refrigeration system that we see on sites. We'll then go through some typical energy saving opportunities, and then go into some detail on case studies and the Green Business Fund and how that can help or may help your site with refrigeration systems. So a quick introduction on the Carbon Trust for those of you that are less familiar. We've been around since 2001. We're a not-for-profit organisation, mission-driven to accelerate to a sustainable low-carbon economy. We're independent, and we're experts on carbon reduction and resource efficiency. 3 key services that we provide are advice, footprinting, and technology. Green Business Fund really falls into the advice element of what we do. You see the other services there that we also provide. So the aim of this webinar is to improve the understanding of refrigeration systems generally and the typical types of refrigeration systems we see. Develop understanding of how improved controls, management practices and new technology can deliver cost-effective energy savings, and we have tried to focus on cost-effective energy savings because those are the ones that are perhaps easier to action for a larger percentage of businesses. Understanding the importance of good maintenance and how imperative that is for efficient system operation. We'll give you some case studies of and examples of people who have saved energy by optimizing their refrigeration systems, and then ultimately describe how the Green Business Fund could potentially help. So before we move into detail, it's worth considering why we're thinking about energy efficiency in refrigeration systems and really why it's important. Well, the figures that we have here, obviously these are approximations from our findings, but this is typically what we see when we work with businesses in these particular sectors. In the meat, poultry and fish processing businesses, the proportion of energy costs that are accounted for by refrigeration are typically around the 50% mark. Cold storage, it could be up to 90%. Food supermarkets, again, it could be 50%. Small shops, refrigerated cabinets could be 70% or over, and pubs and clubs about 30%. So against these high costs, even a small reduction in refrigeration energy use can offer significant cost savings to a business, and ultimately resulting in increased profits. So this is the reason for this webinar, and the reason for focusing on energy efficiency in refrigeration, because it is such a significant impactor for bottom line costs in a business. Now, energy saving in refrigeration, it's really easier to understand when you have an understanding of the system and how it works at its most basic level. Now, again, apologies if this is familiar information to some of you who are maybe working in the refrigeration sector quite a bit, but it's worth just to reiterate that we're trying to cover all bases with this presentation. So, in very basic terms, refrigeration is a process in which work is done to move heat from one location to another. And in principle, that is moving heat, in the most common terms that we see, from a low temperature reservoir, which is really your fridge or cold store. The heat will be absorbed by the refrigeration, work will be done, that heat will be transported, typically externally, to a high temperature reservoir where it will be dumped. And the work of heat transport is traditionally driven by mechanical work within the refrigeration system. Now, there are many types of different refrigeration systems, but by far the most common that we see is a simplified vapor compression cycle. And again, this is just to move heat from one location to another. Typically, it consists of the elements shown there on the screen. So we have the evaporator internally within the cold store or fridge. We have a compressor, which does a majority of the work. We have the condenser, typically located externally, which rejects the heat, and an expansion device. And we're just going to go through here the quick steps that this particular cycle runs through in order to move heat from typically the evaporator to reject it at the condenser. So if we start inside the cold room, fridge or freezer, for energy efficiency you want to make it as easy as possible to collect heat. So this is what we typically focus on doing for the evaporator. And at this point you have quite a low pressure liquid refrigerant as it goes to the evaporator. The evaporator absorbs the heat that's in the cold space, refrigerated space, and this will convert the heat to a gas, which will then leave the evaporator and go off to the compressor. It's important to remember that during this cycle that pressure is proportional to temperature, and this cycle uses this process to move heat from one location to another. So within the fridge, regardless of how cold it is, there will be thermal energy there to collect at the evaporator. Now, moving that gas then goes on to the compressor, and at the compressor the pressure of the gas is raised, which raises the temperature. Typically that raises it above the external ambient temperature before it's sent out to the condenser to reject that heat. Now, this is the real energy intensive part of the process, so reducing the work of this system is often the focus of energy saving initiatives, and we'll talk about some ways in which you can do that later on in the presentation. Going externally, typically to where the heat is rejected, so this high pressure superheated vapor is then sent outside, typically at a temperature higher than the external ambient, and heat will be rejected or dumped out into the atmosphere as the liquid rejects its latent heat. And again, the importance of energy efficiency with relation to the condenser is primarily just making it as easy as possible for that condenser to dump the heat outside. Then once that heat's been dumped, again considering the relationship with pressure and temperature, use an expansion device to send the pressure down, decrease the temperature before it re-enters back into the evaporator in your cold store or fridge back to collect heat. This is often simply a valve with little or no energy consumption. And that really completes the cycle. Simple, it works, but you need to do what you can to make each element do as little work as possible to optimize the efficiency of the system. So what are the typical types of refrigeration system we see? Well, on the low pressure side, with the evaporators, these are the systems that collect the thermal energy from the local environment or from a product. We typically see cold stores, which are used to cool air, so walk-in cold rooms and freezers. We also have display cabinets, which if you're in the retail environment, I'm sure you're very familiar with. On a process side of things, you may look to use a refrigeration system to cool a liquid, to gather heat from a process to help cool the process for a plate heat exchanger. So these are some of the more common variations that we see on the low pressure side with the evaporators. On the high pressure side, where we're dumping heat, most common we'd see would be air-cooled condensers, dumping heat externally. They simply blow air over the refrigerant to cool and condense the refrigerant. The evaporated condensers, typically for larger systems, and use the evaporation of water to aid the cooling process, often with the assistance of water. And larger water-cooled systems at the bottom are typically used in larger systems and typically work in conjunction with a cooling tower. So these are some of the typical elements we see on external heat rejection elements. And as discussed during the discussion of the vapor cycle, compressors and expansion devices are key elements in the system. Compressors can include scroll, reciprocating, or screw-type compressors, and they are often installed in multiples to improve part load operation. They're typically more efficient when they operate fully loaded. And as mentioned previously, expansion devices are often just valves with little, if any, energy consumption. Chillers, some of you may have chillers on your site. They're used in both industrial and commercial situations to produce chilled water, glycol, or any other chilled fluid used in a process or air conditioning equipment. Packaged chillers are typically factory assembled, and they're self-contained, and they include refrigeration, compressors, controls, and the evaporator. The condensers might be built to the compressor itself, or they can also be remote. Chillers are typically chosen to meet the maximum cooling load during the warmest weather. However, for a majority of the year, they'll be running at part load and not in these toughest of conditions. So the load will be smaller, or the weather will be cooler, and we'll speak more later in the presentation about the energy efficiency opportunities that this could present for a chiller type system and chiller selection. So that covers some of the key systems that we more commonly see within the refrigeration environment, and there are others, but as I say, we've tried to keep this to focus on the more common elements. Again, if you have particular queries about a particular piece of kit that you may have, please do submit that in a question in the tab, and we will get back to you with your specific queries. So we'll move on to some energy saving opportunities. So we know how the system works, we know in principle, and we know what elements make up that system. So what steps can we take to reduce the energy consumption of these systems? One important thing to consider is that you don't necessarily need to make heavy capital expenditure investments to make savings. From our work and from our studies, energy saving is typically made up of 20% through actions that require little or no investment. Clearly, from the figure you can see there, investment does also have a big impact in the efficient operation of the systems, but just by good housekeeping, good maintenance, and good practice in the operation of the systems, you can make significant savings. And listed here on the right are the key systems and energy efficiency opportunities we're going to look at today. Hopefully some of your systems are included in the list to the right, and we should be able to give you some hints and tips on how to reduce the energy consumption of those systems. So we'll start with display cabinets. So commonly seen in supermarkets, even if you don't work in the retail sector, you'll have seen them. And here we're just giving you some guidance on good housekeeping, good maintenance, and investment measures. So we'll start with the good housekeeping. So really make sure your cabinet isn't overstocked, and keep the air grills clear of product and merchandising. A properly stocked cabinet will maintain optimum food temperatures with minimum energy consumption. Don't allow your products to warm in transfer. So as you load products into your cabinet, make sure it hasn't warmed or being left in ambient temperatures. That'll increase the work for the evaporator. When the shop is closed, use any night blinds and night covers fitted, and switch off lights and any anti-condensation heaters. If there are lights under shelves, consider whether these can be switched off or removed. And check that defrost settings are appropriate. Make sure they're set appropriately to match conditions and to avoid unnecessary heating. These are checks that you can do yourself, and good practice housekeeping that you can do yourself. Maintenance may require some interaction with your maintenance provider for your refrigeration systems. Keep a good cleaning maintenance schedule. This will maintain top efficiency and good temperature control within the display cabinet. Use well-fitting night blinds or covers on all open cabinets to reduce the load during non-trading hours. An ill-fitting night blind or cover is obviously less effective. Ensure all trim and anti-sweat heaters are pulsed or switched off automatically when not needed. And think about possibly fitting anti-mist film or spray, or switching the heaters off permanently if that is an option. Within the display cabinet, ensure all expansion valves are properly fitted and commissioned. You're typically using electronic types where appropriate, as they are more effective. And install auto controls on your defrost systems with temperature cut out to avoid necessary heating. If you're using electric defrosting on a chill cabinet, check whether you need it. Natural or off-cycle defrost might be an option and be more efficient. If you are going to invest in improving the efficiency of your display cabinets, use high efficiency LED canopy lighting. This is very effective. Install transparent doors over the units. I understand that this can sometimes be a challenge with customers accessing products, but it does have a significant impact on your energy saving. And replace fans with lower power alternatives, EC or electrically commutated alternatives. And we've given you some guidance here on what typically you should expect to save by implementing these measures. As you can see, cabinet selection at the outset is key and can have a massive impact on the energy efficiency of the system. But the retrofit options listed from the top down, you can see the cleaning and maintenance has the biggest impact. In terms of investment, the installing transparent doors and LED lighting are probably the two biggest impactors there on energy consumption. So do consider those measures if you operate display cabinet systems. Cold rooms. Really what we're trying to do in the cold room, as we were within the display cabinet, is make the work for the evaporator as easy as possible. So again, we've got housekeeping, maintenance and investment measures. Sounds a very obvious one, but it's one we commonly see on site. Introduce good door management policy within your business if it's not there currently, and it is just an education process, but keeping the door closed can have a massive impact. You can see in the diagram down at the bottom of the slide just exactly where the typical heat gains come from within a cold room, and through the door is often the biggest impact. So really introduce good door management. Ensure evaporators are not extracted. Again, don't overstock and block the evaporator from its operation. Run at the highest temperature you can for the product. I understand there are food safety standards that require certain temperatures, but review those and see how high you can run the temperature within the cold store. Don't allow products to warm in transfer, as described with the display cabinets. If it's in an ambient temperature for a long time and it's going into the store at a warm temperature, it will increase the workload on the evaporator. And switch lights off when not occupied. Again, these are all obvious, but they're all common things that we see when we do energy audits on refrigerated cold store sites. In terms of maintenance, a door is an effective seal, but only if the perimeter sealing is good. And if you have an automatic rapid close door, make sure that they are not overridden by staff and that they're maintained in a good working order. If you can't, or if installing a rapid close door is not viable, strip curtains over the door are effective, as long as they're well maintained. You can see there in the diagram something that's not uncommon, where strips are broken and there are gaps to allow air into the room. Again, that all adds to the work on the system and all impacts your energy consumption. Upgrade the lighting to LED with automatic control. You can link that to the door operation so that it only functions or with a presence detector, so that the lighting only functions when people are in the room. It switches off when there is no occupancy. You can see that it's not. You don't just then save on the energy consumption for the lighting. You also save on potentially the heat gain within the space as well, up to 10% if you've got fluorescent fittings installed. So again, we recommend upgrading to LED, which work well in cold environments. And as well as the door seal, just maintain and repair all wall panel seals around the cold store. If you are going to look to invest in the system and spend a bit more money to improve the efficiency, as I mentioned previously, fitting automatic or rapid close doors, if frequent access is required to the cold store, it can be a good measure to implement. And introduce a defrost on demand system, which will keep evaporators in top condition. For larger forklift accessible cold stores, consider incorporating an airlock dehumidification functionality, just to stop moisture being brought into the cold store on a regular basis, which can cause frost buildup and impact the efficiency of the evaporator. And if you are installing a new cold store, sliding doors are typically more effective than standard opening doors. They create better seals and they're less prone to damage through generally moving through the space and through the site. Compressors. Now, this is where the heavy work is done for the refrigeration system. and it will have the biggest impact on energy saving if the life of the compressor is made as easy as possible. So remember, this is working to raise the pressure of the refrigerant, but also the temperature to above external ambient conditions to reject the heat externally. So again, we've given you some maintenance low-cost measures. There's less housekeeping involved with the compressor typically because it's not something you interact with on a daily basis. But if you do have interaction with the maintenance contractor, it's worth getting your technicians to set the condensing temperature at the lowest practical level. And once the limit is reached, it may be possible to upgrade the control valves or condensing capacity to allow further energy reduction. But you can see here, just with the little example at the bottom, for every degree that temperature lift is reduced, so i.e. the condensing temperature, save around 4% of the compressor energy for a chill system and around 2% for a low temperature system. The example on the graph on this slide shows a typical condensing temperature. This is a poor case, a poor example, bad practice of a consistent 40-degree C condensing temperature all year round. That will continue to reject heat because it will always be above ambient temperature. But as you can see, it's not optimized for efficiency. You don't need to raise the temperature at the compressor that high to reject heat externally. So by adapting the condensing temperature down to 20 degrees when the weather allows, with float controls to raise the condensing temperature as necessary during warmer months. You can see there the light blue line shows good practice, a lower condensing temperature, and you can save between 25 and 35% of the energy consumption on your chilled temperature systems. Again, the compressor is the energy intensive part of the system. Focusing on improving the efficiency of this is critical. On multi-compressor systems, make sure the compressor suction pressure is set only as low as required, and often the winter set point can be higher than summer, but again, it's something to mention to your maintenance technician. And then investment measures, what can we do to improve the efficiency? So if you can't reduce the condensing temperature for your system for any particular reason, you can introduce something called liquid pressure amplification, which is installing essentially a small pump within the refrigeration cycle. Typically this is for larger plant over 300 kilowatts. Typical savings are up to 25% for introducing that, with a payback of 3 to 5 years. Again, this is something that you could potentially discuss with your refrigeration maintenance provider. And if your cooling load varies across a wide range, consider installing speed controllers for one or more of your compressors within the system. Moving on to the condensers, these are, as outlined, typically located externally from the building, and again your focus here is making it as easy as possible to conduct its duty, which is to reject heat. So good housekeeping, often we'll go outside and look at the external condensers and we'll see that detritus and waste from the site is left blocking the airflow around the condenser. Try and keep them clear of leaves, litter, vegetation. If they're dirty and blocked, ultimately they're costing you money. You can see a bad practice example there of some dirty fins on an external condenser that will be having to work harder to reject the heat from the system. With your maintenance contractor, discuss having fins and filters professionally cleaned on a regular basis, and check all fans are operational. Again, you may find that some fans aren't in operation just because the system is operating in part load, but it's worth checking these two things so that the system is rejecting heat effectively. If you do want to make some investments and you are finding that you can't prevent the condenser screen of the condenser fins and filters from getting blocked on a regular basis, you can install removable condenser screens to prevent that blockage and allow continuously free airflow. You can also install additional condensers if they're struggling at peak times. Ultimately, the more space you have, or the more area you have, and the larger the condenser, the more efficiently it can reject heat. So installing an extra condenser is one option. And replace the condenser fans with high efficiency electrically commutated alternatives. Again, that can be quite a good saving measure. If you are purchasing or designing a refrigeration system, think about you may have limited external space, but get the biggest external condenser you can. A properly sized external condenser, by increasing the condenser size by 30% of the time you buy, you can save up to 10% of energy use. So it's well worth getting a big condenser if you can accommodate it outside. And again, just to reiterate, here, if you're having to increase the condensing temperature at the condenser because it's blocked, then a 1 to 2 degrees C, a 1 degree C increase in temperature could be a 2 to 4% increase in compressor energy. So it's definitely something worth considering that. Evaporators. Again, the function of the evaporator is to collect heat, so we want to make this as easy as possible. So even in very, very cold environments, there's still heat there to collect, so we want to make this as effective as possible. So just keep an eye on your evaporators. If you see a permanent buildup of ice on the coil, then it's an indication that something is wrong, and something needs to be discussed with your maintenance provider. Consider switching off, or whether there are evaporators in rooms that are not in use, and switch them off if there's no need to actually be cooling in there. And one to think about is that locating the room thermostat as high as possible in the room without compromising obviously the food or process can reduce consumption. Obviously heat still rises even in these cold environments, so increasing the temperature improves the efficiency of the system. But turning up the thermostat by just 1 degree C, you can potentially reduce your energy use by up to 2%. So definitely look at your temperature set points in the evaporator space. Maintenance and low-cost measures. Just ensure that coil is cleaned as a regular part of routine maintenance. Again, it makes it more effective at collecting heat from the space. Check all fans are functioning correctly. Evaporator drains, there will be fluid that builds up on the evaporator that needs to be drained. Make sure they have traps within that drain so that external air doesn't creep into the system. And insulate that drain. Ultimately, it's carrying liquid that through a cold environment and can freeze. If it blocks, it can impact the operation of the system, let alone its efficiency. So insulate the drains and install trace heating if necessary, and install demand on defrost on demand refrigerate systems in cabinets, and that again that can save up to 9% of energy consumption. You can see some examples at the bottom there. Poor door and defrost control has resulted in a blocked evaporator and increased energy consumption. And on the good practice example, you have a good defrost function plus insulated drain, low energy fans, which has resulted in a clear evaporator and lower energy consumption. So it's quite clear there which system would be operating more efficiently. Heat recovery. Now, refrigeration system, as discussed, is essentially moving thermal energy from one space and delivering it to another, usually outside. But if you want to, you can collect that heat for reusing it. So there's typically two types of heat. There's high grade and low grade. High grade heat is typically collected with the desuperheater or heat exchanger just after the compressor, before the condenser. This typically can be used to provide a small amount of domestic hot water for washing or cleaning. Low-grade heat, as can be seen at the bottom, can either be collected directly from the air-cooled condenser in the form of air inducted in to support space heating, or can be collected actually at the condenser. Typically, this is a much lower temperature. It's closer to 20 degrees C. But for example, that could be used as a boiler feed water preheat, just to lift that water temperature that's going into the boiler system by a few degrees C and reduce the energy consumption needed to lift what would be 10 degrees C water going into the heating system. So a typical mid-sized supermarket in this example, or a small food factory, could have a cooling load of around 230 kilowatts. So the heat rejected to the atmosphere would typically be around 310 kilowatts, and around 10% of this could be collected as relatively high-grade heat, and that's available at 50 to 60 degrees C. Again, could be used to support your hot water demand or provide hot water demand at those kind of temperatures. The rest you can recover, but it's relatively low grade. So again, it can be used to either space heating or as a support to other heating systems. Typically, as a business case, The payback is good, but you're typically looking at 3 to 5 years for a heat recovery system to pay back. This is often due to the high capital cost of the heat exchangers and the additional pipework and controls. But savings are significant though, as you can see, as the heat recovered is essentially free. So definitely worth making an investment or considering an investment in that if you think your site is appropriate. Reducing leakage, through releasing refrigerant gases, it's also costing you money in terms of efficiency. So there's some guidelines here on how often you should be inspecting the system for leaks. Most refrigeration systems have leakage. This can be up to 20%, but typical, and if that is the case, then in a typical system, this level of loss would mean an 11% reduction in energy efficiency and direct decrease in energy costs. If you have a charge of less than 300 kilograms, check for leaks at least once a year. Systems over this size, you should have a leak detection system installed and checks much more regularly. Free cooling, we've touched on this earlier. Again, with when we mentioned increasing condensing temperatures, but if the external ambient conditions are cold enough, then you might not need work for the compressors at all. So this example here shows that the average annual temperature in the UK is below 9 degrees C and below 5 degrees C for around 3 months each year. So many air conditioning systems and factory processes that require chilled water at a relatively high temperature between 10 and 15 degrees C. When the external temperature is colder than the chilled water you need, then free cooling is an option. So you don't need to use a compressor at all. An example here is a manufacturing site where they need some chilled water at 4 degrees C, but some only at 16 degrees C. So the temperature of the chillers couldn't be raised because there are processes here that need chilled water at 4 degrees C, but a free cooler could be used to produce a 16 degrees C water for around 200 days of the year, just using only fans to reject the heat. So the cost of producing that 600 kilowatts of chilled water at 4 degrees C is around £118 a day, or 23,600 pounds a year. A free cooler could deliver that same cooling at a cost of £21 a day, so just £4,200 pounds a year, saving £19,400 per year. So then the cost of the free cooler in this instance was about £4,000 to £5,000 payback in less than 2.5 years, and continue to be used throughout the life of the system. So you can see there the benefits of free cooling, particularly in the environment that we have here in the UK. Chillers, as was discussed, they're package units. We mentioned earlier they contain the evaporators, compressors, expansion valves, and the condensers that could be internal or remote. They're often selected for full load functionality when it's hot outside and they've got full load on the system, but they often don't need to run at that. So choose a chiller or install controls on the chiller which are effective at part load conditions. So the graph right shows 2 chillers with a similar energy efficiency ratio. Chiller A has been engineered to maximize efficiency at part load in cooler weather. There's no clear difference with when the load and temperature are at the highest during summer, but in the winter, the 2 lines shown in blue, Chiller B shows a modest improvement in energy efficiency ratio, but Chiller A has got vastly superior performance, and this will actually be realised for most of the year. So even though there is a cost premium for the superior chiller, this can typically be saved within a couple of years, just by the much more efficient part load operation of the chiller. Pipework insulation, it's again seems an obvious one, but it's a real slow burner, and it will cost you a lot of money in the long run if it's not installed correctly. Thermal imaging can be a useful way of identifying where there is poor insulation, and your maintenance provider may be able to provide this service. All losses throughout the system are work for the compressor and cost money. This example here just shows the impact it can have. So if you're operating a chilled water system with a flow of 7 degrees C and a return temperature of 12 degrees C, at the chiller. The supply temp, if you measure the supply temperature at the end of the pipe work at the cooling load, it may have increased by around half a degree. That heat has been gained without any useful cooling having been done, and a similar heat gain could be experienced on the return line. So in this example case, if the heat gain just through the pipe work is 0.7 degrees C, the system has lost 15% of its cooling capacity. And if the deterioration of the insulation is severe, the losses can be up to 25%. So it's an easy one to spot. If you haven't got refrigeration, if you haven't got insulation on your pipe work, often you'll see frost if you've got cold temperatures. So if you do see it, I would rectify it as quickly as possible. Maintenance, I think we've mentioned all of these as we've gone through the various elements of the system, but this really is a checklist to discuss with your maintenance contractors, and if they're not undertaking some of these activities, I would ask why not. We don't want to just let them get away with minimum compliance checks. Really, they should be checking for efficiency as well and optimizing that for you and providing you with guidance on where efficiency can be improved. So this list here is a useful reminder that you can refer back to if you want to go back into the webinar. But again, you can reduce your energy costs by 50% or more by making sure that your refrigerant plant is well operated and well maintained. So, we've discussed each of these before, so I won't go back over them. But certainly worth raising these with any maintenance providers you have. Last one is monitoring. Again, ask your maintenance contractor what monitoring you have available and how it could be improved. Two things to really monitor: system pressures, really to check that the work, check on the work that the system is doing. So they're beneficial to even smaller systems. A drop in suction pressure could indicate a problem, such as refrigeration leaks, and discharge pressure increasing while ambient temperature remains constant could indicate a blocked condenser. Monitoring temperature conditions is critical. You can see the image on the bottom left of the slide there is from a large supermarket where they're monitoring the temperature of each individual display cabinet and what it's doing, whether it's on the frost cycle. It allows you to really observe in detail how each piece of kit is performing just by looking at that one screen, which is much more beneficial than having the typical little digital display that you have on each refrigerated display cabinet. So monitoring temperature and pressure throughout the system is key. Just one other consideration with refrigeration systems: when purchasing new equipment, think about the full life cost of its operation. So this is the easiest opportunity to maximize refrigeration plant operational efficiency, and really purchase the equipment and understand your refrigeration needs to minimize the load. The example case here is for a slightly more expensive, £1,100 more expensive display cabinet. One consumes 44 kilowatt hours per day, whereas cabinet B, the cheaper alternative, consumes 55 kilowatt hours per day. But during the 10-year life, cabinet B has an energy cost of over £3,500, in excess of those for cabinet A. So over the lifetime, the premium in the purchase cost for cabinet A is more than 3 times over recovered. So do look at that when you're purchasing new equipment. Make it a standard policy within your business to review the life cycle cost of all of your refrigeration plant and make decisions based on that, because it can have a big impact to your ongoing operational costs. This is just provided as a recap before we leave the efficiency opportunities of some of the key points. So for evaporators, keep the temperature high. If you want a large evaporator with the fans working, unrestricted airflow, you keep it clean with no ice buildup, and 1 degrees C higher gives 2 to 4% energy saving. For the condensers, keep the temperature low with a large condenser, clean and undamaged, with minimized head pressure, fans working, a good airflow around the condenser with the airflow as cool as possible. 1 degree C lower could give you a 2 to 4% energy saving. The general and then fabric of your cold store, your cold environment, the good door seal can have 10 to 12% energy saving impact. Strip curtains and airtight seals, again, can both save 2 to 3%. So all just good guidance on what generally to think about with your systems. Some case studies. Just for some context, this is a large supermarket chain that we've worked with, and just demonstrates what they have achieved in some of their small, medium convenience stores. You can see for an older site, the kilowatt hours per square meter is significantly higher than one of their newer refurbished sites. So you can see there the actions that they've taken on some of the new sites and the retrofit sites, such as LED lighting, efficient fans on evaporators and condensers, strip curtains, doors on chilled cabinets, haven't been done on their old stores, and the consumption is much higher than the retrofit site. And although the retrofit site is good, the newly installed equipment site is clearly the most efficient in terms of energy consumption per square meter. So you can really see the impact that these measures that we discussed during this webinar have had. So that's what we're intending to cover for refrigeration systems. I'll move on now to the Green Business Fund in general. So for those of you who are not familiar, what is the Green Business Fund? It's operated by the Carbon Trust to contribute to improve sustainability and energy efficiency. Currently, it serves small to medium businesses in England, Scotland and Wales in 2016 and 17. And the fund today provides a combination of advice, training, direct contribution, and for capital equipment. There is scope for the fund to expand both in the UK and internationally should any additional funding be made available by a suitable body for that purpose. Whilst funds are still available, it is a first-come, first-served basis scheme, so current predictions are that it will run until 2018, but there, as I say, there is potential to extend this, but it is a finite pot, and first-come, first-served. So we're really looking at the most cost-effective, high-quality energy reduction schemes available for our customers, and we would encourage companies that haven't taken action yet and are thinking about taking action on energy efficiency to act. Just some of the eligibility criteria. The map here shows the areas that is currently available, so England, Scotland and Wales. Those eligible for support are small and medium-sized businesses, schools, sole traders, charities. We're not able to support domestic properties, the public sector or new builds, and it's targeted at SMEs, so businesses which meet any two of the criteria listed here would be classed as an SME, so have a look at those and consider whether you would fall into that bracket. So what are the services that you can avail of from the Green Business Fund? So service one, we offer workshops, which are typically 2-hour workshops around the country. They're hosted by Carbon Trust partner, but delivered by the Carbon Trust, to help you understand your energy consumption, give you tips on how to identify low and no cost measures. They're for companies typically with less than 50 employees. And we've trained over 135 companies so far. Upcoming workshops are both down south, but we do them around the country and around the areas supported by the GBF, which can be found on our website. But the next two are first on 5th of July in North London, and the next one after that is 11th of July in Farnborough. And you can apply for these funded services via the Carbon Trust website. The next step is next service that's available is the opportunity assessment. This can be a remote or on-site assessment depending on the size of your business. It's delivered by a Carbon Trust engineer such as myself, and we provide you with recommendations on your top 3 energy-saving opportunities, and give you guidance on the next steps to realise those savings. And it's a tailored appraisal of your energy management approach and energy efficiency of the systems on your site. And again, that's available for SMEs in qualifying geographies. We've got a case study here of a metal pressing company who had an energy audit, which is what I guess you would traditionally know these as, and you can see there the benefits that we helped identify. Implementation advice. this is the only service which is aimed at non-large companies, so companies bigger than SMEs. The primary reason for this is because it was just provide some implementation support to companies that may have completed ESOS, which is a scheme aimed at energy auditing for large businesses. It can provide up to 5 days support with a Carbon Trust consultant to assist on implementation of the projects. Typically that's tender support. Companies that want to avail of this service should have a business case for a project ready for investment and ready to invite quotes from and to select suppliers. And again, we've got a case study here of a charity which availed of this service to undertake an LED replacement within their sports hall. And we provided a short list of suppliers and supported them through the tender process, providing impartial advice. Just going to give you some additional guidance on other schemes. That was it for the Green Business Fund. So this is some other initiatives that we're involved with. So interest-free energy efficiency loans are also available. It's designed to support businesses in upgrading to more efficient equipment and renewables. These are some of the services that can be supported by the interest-free energy efficiency loans, but these are only available to businesses in Wales and Northern Ireland. So for Welsh SMEs, they can borrow £3,000 to £200,000, and Northern Ireland businesses of all sizes can borrow £3,000 to £400,000. Again, just Wales and Northern Ireland for the energy efficiency loans. And the loan offer is based on carbon savings. The project can deliver £1,000 for every 1.5 tonnes of CO2 saved annually. Interest-free energy efficiency loans. The loans are, again, just designed so that in most cases the monthly repayment amount will be similar to the reduction in the customer's monthly energy bill. Savings are sense checked by engineers to provide assurance that they may be achieved. Loans are interest-free, unsecured, and have no setup fees. Businesses in Wales can apply for both an interest-free loan and the Green Business Fund, which can give you up to £10,000 capital contribution, as already discussed. And for more details on that, visit these web pages provided here. The energy technology list is a good place to go to identify equipment if you are looking to make plant upgrades. If it is ETL compliant, there are more than 16,000 products in 57 technology categories, refrigeration being one of them. But what it allows you to do is, when on the purchase, it means you can get all of the tax benefit in the year of purchase recovered. So the benefit to an organisation spending £10,000 on a piece of ETL equipment could be £2,000. So it's definitely worth considering when you're looking at purchasing new equipment. And again, further guidance on that you can ping queries to the email address here, or you can get further information from our website at the address at the bottom. So that's it for the webinar. That's everything we're intending to cover today. I'll have a review here and see if we've got any particular questions. I do appreciate that we've kind of come to the end of the hour slot, but I'll see if there's any particular queries that have been raised. We do have one query. It's regarding solar thermal systems being used to reduce the demand on compressors. Is this something that we've come across in practice in the UK, and is it currently a cost-effective option? I think this isn't in answer to that query using solar thermal. I mean, ultimately, what you're doing there is using the thermal energy from the sun to reduce, to increase the temperature of the refrigerant. So you are reducing the demand on the compressor. It's not something that I personally have seen in practice. I have heard of it being done, and it's certainly not something I come across often. Is it a cost-effective option? I think because it would be a relatively novel approach compared to what you typically see around the country, I would suggest that it would be rather specialised and therefore slightly more expensive to implement, but clearly you will make good energy savings if you are able to use that energy. It also depends on what temperature you are looking to raise. You're looking to raise your refrigerant to within that system. If it's particularly high external temperature, then you may get some gains, but they may be limited. As I say, it's not something I've come across that often, but I would certainly be happy to share what information I do have with you on those systems, Tom, to give you a bit more info on that. But as I say, certainly it's just a relatively new approach that we don't see that often. That was it for the questions we've had to date. If you do have any other queries, please do send them in. I'm happy to answer them. Otherwise, thank you very much for attending today's webinar. Please contact greenbusiness@carbontrust.com or give us a call on 020 7832 4773. On the behalf of the Carbon Trust, thank you for joining me today, and I hope you all enjoy the rest of the day and have taken something from the presentation. Thank you very much, and have a good day. Thank you.